Hi everyone! Today, we're diving into a fundamental aspect of microcontroller communication, the RX and TX pins, specifically how they work on the powerful esp32 board. Understanding these pins is crucial for connecting your esp32 to a wide range of external devices. We'll explore what they are, how the esp32 handles them differently from traditional Arduinos, and how you can use them effectively in your projects. At its core, RX stands for receive and TX stands for transmit. These two pins form a simple serial communication channel. Data travels out of the TX pin of one device and into the RX pin of another, and vice versa. It's like a two-way conversation line. Many common devices, such as GPS modules, Bluetooth modules, RFID readers, and even other microcontrollers, use this serial communication method. Traditional Arduino boards typically have one hardware serial port, often mapped to digital pins 0, RX, and 1, TX. This is straightforward but can be limiting if you need to talk to multiple devices simultaneously or if those pins are needed for other functions. The esp32, however, offers much greater flexibility. It boasts multiple hardware serial ports, often referred to as UARTs, Universal Asynchronous Receiver Transmitter. The esp32 actually has three UARTs, UART0, UART1, and UART2. UART0 is the default serial port. It's primarily used for flashing firmware to your esp32 and for sending debug messages to your computer's serial monitor. Its TX pin is typically GPIO1 and its RX pin is GPIO3. When you use serial.begin in your Arduino IDE code, you are interacting with UART0. The real power comes with UART1 and UART2. Unlike many other microcontrollers, the esp32 allows you to remap the RX and TX pins for UART1 and UART2 to almost any available GPIO pin. This is an incredible feature that provides immense flexibility in your project layouts. You are not stuck with fixed pins. To use these additional serial ports in the Arduino IDE, you'll use the Serial1 and Serial2 objects. For example, to initialize Serial1, you would use a command like serial1.begin, baud_rate, serial_8n1, rx_GPIO_pin, tx_GPIO_pin. Here, baud_rate sets the communication speed. Serial_8n1 is a standard data format, 8 data bits, no parity, 1 stop bit, and rx_GPIO_pin and tx_GPIO_pin are the specific esp32 GPIO numbers you've chosen for receiving and transmitting, respectively. The same syntax applies to Serial2. When connecting devices, always remember the cardinal rule: connect the TX of one device to the RX of the other, and the RX of the first device to the TX of the second. It's a cross-connection. Also, be mindful of voltage levels. The esp32 operates at 3.3 V. If you're connecting it to a 5 V device, you'll need a logic level shifter to prevent damage. Avoid using GPIO1 and GPIO3 for other purposes if you rely on the serial monitor for debugging, as this can interfere with communication with your computer. This ability to define multiple serial ports on custom pins makes the esp32 incredibly versatile for complex projects requiring communication with several peripherals. Thank you so much for watching this video. I hope this explanation of RX and TX pins on the esp32 has been clear and helpful for your projects. If you found this information useful, please give this video a thumbs up. Don't forget to subscribe to the channel for more tutorials and tips on Arduino, esp32, and electronics. Your support helps us create more content like this.